All right, here we are at Serverless Office Hours. Biswanath, how are you, sir?
I'm doing great. Thanks, Eric. How are you?
I'm doing good. Props to you. So, just for those of you watching, first of all, you know the drill. If you're watching this, go ahead and throw in where you're watching from. We like to say howdy, hello. But I'm not sure many of you are watching or participating from as far away as Biswanath. Biswanath, tell them where you are.
I'm based out of India, Bangalore at present.
That's right. Yeah. Bangalore. I love Bangalore. The food is amazing.
Yeah,
It's hot. It's a little spicy, but yeah, I love it. So, super glad you're here. If you've never watched Serverless Office Hours before, Serverless Office Hours talks all about serverless. This is a great place to learn about AWS serverless, and of course, we answer questions. We talk about all kinds of things. And today, of course, everybody loves the idea of AI and Gen AI and why serverless works with AI. But today, tell them what we're going to talk about. Give them kind of a preview of what we're going to talk about.
yeah. So it's just a Gen AI world today, right? Everything we talk about generative AI, agentic AI, and all that. So today we are going to take up one of the popular use cases that many of our customers are interested in. That's about how do we improve operations using agentic AI. So you're talking about agentic AIOps with AWS generative AI services.
All right. So this is kind of we talk about developing and the agentic stuff and things like that, but this is the everyday workflow, right? The everyday. I'm not trying to generalize it. This is still really cool stuff, but it's the stuff that we have to get done that takes a lot of time, and so we can point AI at it as well. Super cool. So we're getting a lot of folks coming in. We got Brazil. We've got LA. We've got some more in Bangalore. All right, so Adil Mohammed there. So I say Bangalore still sometimes trying to be cool, or it's Bangalore. So I don't know which do you say?
I say Bangalore. I'm
Okay,
I'm
all
not
right,
native to Bangalore. I migrated to Bangalore very recently, so I still say the English name rather than the local
got it,
Bangalore name.
got it. All right. When I was in Chennai, I was trying to sound really cool. I don't even say Chennai right, which one of our colleagues, Uma, is from Chennai and says she laughs at me every time I say it. But I like to say Madras. What's up?
Ah,
How cool is that, huh? Yeah, there we go. Yeah, he said Bangalore sounds perfect. Nice. Thank you, Adil. I appreciate that. All right. San Diego, California. Right, Joe. He's AWS. Thanks for joining us, Joe. All right, so let's go ahead and just real quick, a couple things I'm gonna throw out there. I was saying it earlier. If you're not familiar with Serverless Office Hours, we meet every Tuesday at the same time, same place. We're on Twitch, we're on YouTube. Sometimes we're on LinkedIn, but Twitch and YouTube are the safe ones. And then we talk about serverless and everything serverless. We have, again, we meet every Tuesday. We have some things coming up. If you're in the Bangalore area, I am going to throw this out there. I don't have a slide or anything, but I hope you know that we have a whole group of serverless folks coming to you on August 8th. And I'm going to paste a link in here after Bishwan starts talking here. I'm going to paste a link. We have a Go to Serverless where I and a bunch of my colleagues are coming to India. And we're going to be talking about, we have workshops, we have sessions. It's a 3-track session. We have like 27 speakers from all around the world to talk about serverless and how large companies are using serverless and different things like that. So I really encourage you to check that out. We have Higgy Park. Higgy, I don't know who you are. You are unknown to me. That's not true. Higgy's coming out of New Jersey. Higgy is ex AWS. Actually, he is AWS now. He used to work in my team. It's not fair to say ex AWS. He still works for AWS. I just told him he was dead to me a while back. So, all right, enough personal stories. Let's jump in. I'm going to bring your screen up if you're ready.
yep.
Let's jump into what we're going to talk about today. Yeah, sorry, Higgy, that slipped out. Okay, here we go. Agentic AIOps on AWS. And first of all, before we go forward, Biswanath, how close am I getting?
Yep. It's pretty, close to how I would pronounce my name. Vishwanath, that's
Okay.
absolutely right.
All right. And your last name, Mukherjee?
Mukherjee. Yep. You're pretty good at
What's up?
Indian names right now. You are visiting India quite often, I can see.
I'm basically Indian. Yeah, I'm south. Would I be south or north? I don't know. It's not important. So, all right, okay. Someone's telling me I'm too much here. That's probably. Thank you, Justin. That's probably true. My wife would tell you the same thing. So, all right. So I'm going to turn it over to Biswanath and go for it, and I'll be posting those links for you.
Sure. Thanks, Eric. And hello, everyone. So let's get started with this. For a brief introduction, I'm a senior solutions architect. I work with strategic customers of AWS. Today, we are going to discuss about how we can use generative AI on AWS to build agentic AI ops solutions. So let's first discuss about what is the problem that we are trying to solve for our customers. So let's say customer is having a global application which is live 24/7, and all of a sudden something goes wrong. So what happens? The operations teams gets involved. How do they get involved? So probably there is some notifications alert coming in from internal tool, or even worse, a call from an angry customer, or maybe some ticket raised through some of the systems that customer has. And then it goes through a series of cycle. Most of our enterprise grade customers have a system which is quite complex in nature. It may not be a single standalone application, meaning that there are multiple systems involved. So very soon a small call turns into a multi-team involvement call, and all this back and forth communications ends up taking a lot of time. They end up spending a lot of time figuring out what's wrong and how to navigate that journey. Now, these are common problems that we see. So if we try to summarize that whole life cycle of a operation guy, it has multifaceted problem. First of all, there is a manual effort involved in identifying and diagnosing the problem. And once that is diagnosed, how do they fix that problem? There would be a runbook depending on the use case that or the problem statement in hand. And then they would have to run those manually step by step. And this is where also the human interpretation comes into the picture. If the runbook is not well documented, the interpretations of that, and even if it's well documented, how that is being actually executed matters from one individual to another individual. And another aspect of that is while that is getting executed, unless somebody is manually updating maybe the ticket or maybe updating somewhere in the call, we kind of lack the visibility of what's going on there, how much of the problem is fixed, where we are, and all that. So we kind of get into a problem where we are lacking visibility, and also how human beings are reacting to that particular problem. So what we are going to discuss about how we can use AWS generative AI services to address this problem. Here, the objective is for the acceleration, not as a complete replacement. We do need humans. I'll also call out where and how much. But here, the solution that we are going to talk about using different AWS generative AI services, how we can accelerate the resolution.
That's always the thing we say. So but we still need humans. So I mean, it comforts me. So yeah. And as we use this, obviously we do. So all right. Sorry, no point to that. Good.
Sure. So before we jump into the different solutions, I just wanted to bring this generative AI stack, that the way we look at generative AI solutions for our customers. And as you understand, based on our work experience with hundreds and thousands of customers on this space, that no two customers are identical. Their use cases are very much their own, as well as their expertise varies. So depending on that, we have this three-stack approach for generative AI solutions for a customer. Right at the bottom, we have the infrastructure layer. This is for the customers who are deep into AI ML space. They wanted to build everything from ground up. They just need the infrastructural support for customers. So that's where we have purpose-built solutions like AWS Trainium and AWS Inferentia to help them with faster as well as cost-optimized solutions for training and inferencing the model. On the other hand, Amazon SageMaker AI is an end-to-end AI ML service where you can build, train, maintain, operate your end-to-end AI ML solution. So this is for the customers who are deep into AI ML space. But then we also have customers who are not that deep onto that, meaning that they wanted to leverage something out there in the market. And what is better place than going to a single place and find something that you'd like to evaluate in all possible options. So for example, if I try to do a comparison, like if you wanted to look for a pair of shoes and you go to amazon.com and search for it, so you get all the options. You get shoes from different brands, different colors, different sizes. in a single place. So you can try to draw an analogy here. Amazon Bedrock is a single place where you can have access to models from the leading model providers using a single API. Today, you might be thinking about model A is best suitable for me. But as we know, this space is so much evolving every day. Tomorrow, you might want to move to model B. In that case, all you need to do is to switch the model ID. It's the same API that you would be using. Had you been interacting directly with the different model providers, you had to take care of the integration part while you change from model A to model B or likewise.
So here's a fun thing. And we talk, I'm interrupting you. And I warned you that I would interrupt you a lot. So one of the cool things, if you're doing, now, by this slide we're looking at, obviously, we're talking about not just different models, but we're talking about different usages for Gen AI, right? So look, for those who consume it, kind of the queue, the developer, those who are building it for others, Amazon Bedrock, and those who are building their own models and stuff. But it's interesting in Bedrock. I was shown this example. It's been a couple of service office hours ago, but if you build for Bedrock, step functions is a really cool approach to this. And the reason for that is, and it's just what Biswanath said, we want to see what other models are doing. And sometimes we do that by doing prompt routing, right? We say, hey, if you're summarizing, use this model, versus if you're doing more, deeper logic, deeper reasoning, use this model, things like that. And we can move around in the families. But sometimes we want to go, look, I want to compare Llama, Nova, Sonnet. What's that other one? Claude. Yeah, do those other ones. I want to see how they come out. A really cool trick if you use step functions is to take and use a past state to build your prompt. And it could be, you can use a Lambda function too, but let's say you use a past state to build your prompt, and then use the converse API. I never know how to say that right. And then that converse API can pass to parallel, where you can hit as many models as you want. And it makes it super easy to say, which model gave me the answer I liked, which did it the fastest, what's the balance. So it's a really cool way of doing that. So just throwing that out there. I've got a pattern of that somewhere. If you're interested, hit me on Twitter and I'll share it.
Absolutely. Thanks for pitching it. Yes, absolutely right. I mean, it's just a lot more than just model selection. There are a lot more use cases around this, and there are a lot more nuances, especially under security, especially around implementing guardrails, which is very important while we are building about generative AI use cases. Now, moving to the top layer, which is even one layer of abstraction, if you don't want to spend time in selecting the right model for use case. So that's where we have the umbrella of services, Amazon Q, and there are 5 different flavors of that. I have shown 2 because we'll be discussing these 2 of them, but there are 5 different flavors of it, and they are for very specific use cases. Amazon Q Business, Amazon Q Developer, Q in QuickSight, Q in Supply Chain. So there are different use cases for each of them, and we have very purpose-built solutions around that. And today, we are going to focus on these 3 services. But first, I'll talk about Amazon Bedrock to start with for the AIOps use case. So remember that we are talking about having operational issues and how we can address those to accelerate the journey, not to replace the journey. I keep repeating that. So we'll talk about that. We already discussed about what is Bedrock. So probably for the interest of time, I can quickly skip this slide if that is okay. But we are going to use Bedrock right now. Sorry, please go on if there's a question.
No, go ahead. I was saying, I was giving you permission to skip the slide. You didn't need it, but there it is. So yeah.
Sure. This is the overall architecture while we would be solving AIOps using Amazon Bedrock. So let's go through this in pieces. So first of all, we have the operational runbooks, right, or SOPs, so which we would be using to create a vector embedding. As we know that vector embedding is the numerical representation of the natural language, be it English or any other language. So here we have these operational runbooks or SOPs, which are maintained by the operations team. So first, those will be converted into vector embedding. In this case, I have used Amazon Open Source Serverless as the vector search engine, but as we know that there are at present 5, if I'm not outdated, is always evolving, right? 5 different databases currently supported as like inbuilt one. So we can choose any one of them as well. So that's the first step as a prep, that we create the vector embedding. Next step is the star of the show, which is the agent. Now, what is an agent? Think of agent like a human being who has brain, also who has some tools. Now, brain in this case is going to be the underlying foundation model, but then that brain also needs the tools to execute certain tasks. So those tools will be provided by the agents, provided to the agents using OpenAPI specification, right? So that's a specification that we use, and underneath those are implemented by Lambda function. So that's where you have access to different other services. And not only, what I wanted to call out here, this particular solution is not only just applicable for AWS. In many cases, we see that customer has a hybrid solutions portion of their architecture on AWS, whereas some portion of it on premise, for example. So using this architecture, it can be extended even beyond that, as long as the Lambda function, for example, have access to the APIs to invoke for the components, architecture component, which is outside of AWS. This architecture can be extended to support that. Now, then the next question becomes, how do we invoke those agents? So we have, again, API-based solutions. We have invoke API, invoke agent API, which can be invoked from anywhere else. So where it can be invoked. So for example, it can be part of another APM systems which can invoke. Maybe it's a ServiceNow ticket that got created. So from there, based on that event, it can be triggered. Or maybe you wanted to have a scheduled health check and make a remediation action based on that. So it's totally up to you. Any system that can invoke an API through which it can be invoked. So that's the overall architecture. For demonstration, however, I would be probably taking a little bit of shortcut. I'll be logging into the AWS console, where it provides a chat interface within the agent, Bedrock agent, and I'll be using that to ask queries about, there are operational issues or not, how do you fix it, those kind of queries that I would be asking. Any questions around the architecture before I move to the demonstration?
So the architecture, and I'm watching here. If anybody has any questions, pop it in. Ward Biswanath, I will interrupt him, like, no problem. So if you have a question, throw it out there. I do have a question. When we talk agent, what are we using for the agent? I'm curious.
Yeah, so we are right now going to see that in the agent. Pretty much what are the components
the gun, okay.
Yeah. Sure.
Okay. So I'm really excited to see, because this is something I'm obviously, like everybody else, I'm working on agents, I'm building agents and stuff. So I'm curious to see how you approach that. But and I've been asking in the background, like, what are favorite? So we have, how many people are using Q? What are some of the favorite Q flavors, Q CLIs coming up? Another one that I really like is the Q. I like the Q browser, which I think is part of the Q business. That's a really cool. So. All right, so we do have a question coming in. Higgy is asking, what type of data are you putting in the knowledge base? So that's like, I hate to say it, Higgy's smarter than I give him credit for. It's a really good question, because how are we dealing with these AIOps stuff, and this would be really important.
Yeah, absolutely. So it's up to our customers' operations team to decide on what they wanted to have the vector embedding on, which will enable the agent to perform that action. In this case, the use case that I have taken is troubleshooting an EC2 instance. That EC2 instance would have high CPU utilization. I'll probably show you the demonstrations. In this case, what I have used is a runbook, how to address a highly traced CPU, highly stressed EC2 instance, right? So that is the runbook that I'll be using, but it's up to customers that would kind of SOPs that we wanted to use for the vector embedding. So this is basically the knowledge base that we wanted to create, so that agent knows what it needs to perform, right?
Cool. Thank you.
So without any further ado, probably it's better that we get into the action, which is the demonstration part of it. So this is the runbook that I was talking about. And as you see, that is written in plain English language, and it addresses how different steps to address high CPU utilization. So here I have like 3 steps. First is take a snapshot, then restart the EC2 instance, and then send an email to operational guys. So it can be 10 steps. It doesn't matter. It will all be read by the Bedrock agent, and it will perform this action. And as you see, this is high CPU utilization. So in real life, I'll have different runbooks for different kinds of issues. And this is where you first create the knowledge base. So first I'll create that knowledge base. How do you do that? It's pretty simple from the console. only a series of clicks, or even you can use that infrastructure as a code to build that using that same data source. However, this is one of the data source. Under preview, we do support other data source, for example, Confluence page or web crawling, as well as we support structured databases like Redshift. So here in this case, I'm using. So if there is a question, please feel free to stop. I just heard some hums. If there is just a note, that's fine.
Oh yeah, no, that's just me. I can't sit here quietly. That's just not my gift. So yeah, I will make it very clear when I'm interrupting. But yeah, sorry about that.
Sure. So this is the agent configuration. As you see, that the brain is the Claude 3 Haiku, and then it is very important that we give specific instruction to the agent. This is like defining a job role for a human being. For example, here specifically.
Can you make that just a little bigger, just so we can see that text real quick? Just like a Control Plus, or just blow it up just a bit.
Okay,
that'll work. Yeah, that'll work.
Yeah. Okay, so I'll probably just go back also if that is allowed.
Yeah, sorry. Yeah. If you can't, don't sweat it. Yeah.
Okay, I'll probably just see if I can go back to this demonstration from the very beginning. And okay, yeah, I think I can. And then I'll do plus.
Okay, so, gotcha.
It will just repeat that same section, and then it will come. Yeah.
No problem. My bad. This is on me. Yep.
No. I mean, I can totally understand. So, so this is the runbook which you have already seen. The objective is that we'll first create a knowledge base out of it. And the way to do that is like either you use S3, or if you have any other kind of data sources, you can use that as well. We support other data sources, even structured data sources supported starting this year via Redshift. So this is where we create the knowledge base. And once you create the knowledge base, which is pretty much intuitive process, either through the console or through any infrastructure as a code method, you do synchronize the data to create the vector embedding, and then you create the agent. So the way we create the agent is for us to decide the brain, which is the Claude 3 Haiku, and then we define the instruction. This is the job role. This is where you specifically mention what do you want that agent to be. So for example, in this case, I mentioned that fix the operational issues and follow the runbook strictly. Do not do anything beyond the runbook, even though Haiku might have its own knowledge to fix an EC2 instance, but don't do that. Follow the runbook. If runbook says 3 instances, 3 steps, just follow the 3 steps. This is where you specify the knowledge base. This is where you basically say that, okay, follow this runbook steps. What are the tools that you have available? And then how do you interact with the system? So that's where the tools are provided via this action group. And these action groups are defined using Open API specification, which is down below you see. Now, here is very important that we be as descriptive as possible, because these descriptions, along with the naming patterns, will be used by that LLM, which is a Haiku in this case, to determine, depending on the incoming prompt or incoming request, which one to invoke. Now, how do we use that? So this is on CPU. So probably I'll just go back to the normals. Okay, so this is a
that's fine.
EC2 instance where I have introduced trace, and that's just by introducing some command. As you see that there's threshold limit of 70% CPU utilization, which has been breached. So this instance is currently under the alarm. So I'm going to ask a question. This is the test agent. Now this could have been invoked by another tool or anything using that invoke agent API. So here I'm asking a question. Can you please check operational issues in my account? I did not be very explicit what I'm looking for, but I just gave like any operational. So in this case, based on the CloudWatch alarm, it identified, hey, there is an EC2 instance. In order to fix that, these are the steps that I need to perform as per the runbook information that I have. But as I mentioned in the instruction, don't perform this activity right away. Look for my permission. So it says that, okay, please give me a go ahead, then I'll perform this action. Now, this is where the human in the loop is important, because let's say if you are troubleshooting a lower environment, it might be okay to take a disruptive action. But if it is something like on a higher environment, you might not want agent to take that action on its own. You might want it to have a human being to validate that this is actually something that you want agent to perform. It's completely up to our customers how much they wanted to rely solely on agent and where they wanted to bring human in the loops, so which is very important. So that's why we wanted to have this part of this demonstration, that you decide whether you wanted to do that completely autonomously or you wanted to have, and then of course once you give a go ahead, these are the steps that happens. For example, snapshot got created. As we see, the first line, it is still getting created. We'll also go to the EC2 instances to check whether it's getting rebooted and everything. So that's the kind of way. So for example, here you see that the system will power off now. That's which was the step 2, and then operational email would be sent. Of course, that's another email that was sent to a different email ID. And then if you see the utilization, it has gone down because the CPU utilization has gone down because of the restart and all that. So it's completely based on what is defined on the runbook. Any questions on this architecture, how this works around this, if we move to the next service?
No, I don't have any coming in at the moment. I probably have some questions for you, but let's do the next service first. So,
sure. So before I do that, I just wanted to mention that this is also available as a workshop on a public link. And Eric, if you have the link handy, if you
I
could.
do. Yep.
So if you wanted to do this on your own account, the demonstration that I showed with you, we have the step-by-step guidance there. Also, you can scan the QR code in case you are watching it later, maybe. So this is something that you can pretty much replicate what I just showed you in a very quick time. We talked about Amazon Bedrock, and we took one of the use cases, operational use case to solve using Bedrock. But now let's look into the higher level of architect abstraction, if I may call it, for generative AI service, where you don't even need to choose the model. In this case, the previous case we chose Haiku, for example. But in Q-Business, that heavy lifting is done by AWS. Depending on the requirement that you have, it will choose the right model for you. So I believe we all know what is Q-Business. Just at a very high level, it helps you break organization silos. As often that we see that the data is distributed in a large enterprise in different systems, maybe some part of in Confluence, some part of in Jira, something in the database and all that. So how you can build a solution which can connect to all these different set of systems and give you an information. And not only it can give you the information, it can also take action on behalf of you using something called plugin. And that's exactly what we are going to use as a custom plugin for our solutions for AIOps, because we not only wanted to understand if anything goes wrong, which is a read operation, but also we wanted to remediate, which is a write operation. So how does this work? The architecture.
Yep. Before we go down this, I want to catch this so we're not winding back so much. I do have a question that came in, and this I think applies to the last section, but we probably this one as well. But the question was, what services does this agent approach support? So if we're running this agent that you were kind of running, what services would that support? I have my answer, but I'm curious what your answer is.
Yeah, right. So if you're talking about the previous demonstration where we are using the Bedrock agent, so Bedrock agent uses Open API specification, and those specifications are implemented at present by AWS Lambda function. So it supports AWS Lambda function to implement those specifications. If that is the question that you're asking about.
I think the question more is, what services would this apply to? Like your example was an EC2 instance spiking. What other services would this be helpful with?
That is pretty much any AWS services and even beyond, because if you see that it's kind of similar architecture, I'm explaining it on this one. AWS Lambda, for example, can talk to S3 bucket, it can talk to EC2 instance, any other services. So as long as you have the API connectivity to whatever destination that you wanted to talk to, it will work. So that service need not be even within AWS for that matter. If you are having an on-premise workload, but you have an API exposed which can be invoked by Lambda function, it will work.
Yeah. It also matters, like you gave it some very specific information in a RAG database, in a knowledge base, right? So, So obviously we have, and you were very specific on use the run book. Don't do your own stuff, but use the run book. We could open that up a little bit and say, hey, you try to fix it for refer to this run book. But you could add runbook for different services. Let's say you were trying to troubleshoot something going on with, RDB or RDS, sorry, or something else. So you could give it different runbooks on that, and it would know how to get that information.
Absolutely, that's right. So that like our architecture and the demonstration that showed you for one specific use case, but that architecture blueprint is expandable, quite widely, be it AWS or even managing resources outside of AWS.
Yep.
Okay.
All right. I think that's our only question. We had a follow up. He just said it's very powerful. That's true. He or she actually, I don't know. So there you go. All right, back to you. Yep.
Sure. So moving on to this architecture, now we are back on Amazon Q business. So overall architecture kind of similar in nature, but then one level of abstraction, that is not choosing the model. The model would be decided by Amazon Q business internally, depending on the use case that you are going to perform. How we are going to integrate, how we are going to get that kind of agentic solution here. Here we'll be using something called custom plugin. Again, it uses Open API specification to get those tools, right? Eventually, you need the tools to perform certain actions for you. How you provide that? In this case, there is slight difference. That is not just AWS Lambda function. This specification can be provided even without Lambda function or anything. So down below, I have mentioned about ECS, EKS. As long as you are providing an API which is accessible from the custom plugin, this solution would work. And on whatever you see on the right-hand side, as one of the questions was asked, what services it can manage? Pretty much everything. As long as you have API access to that specific service or destination, maybe even, for example, on-premise resources you wanted to manage through the same architecture, because you are on a kind of hybrid architecture, some part of it on AWS, whereas some part of it still lives on-premise. You can still leverage this architecture to manage both through the single solution. How does it get invoked? One of the differentiator here also, that it provides you built-in UI which you can leverage, and also it provides an API to integrate with. So it has an inbuilt chat interface through which you can use that this solution. However, if you wanted to integrate with your existing solution, maybe a website that you have on which you wanted to have your own custom chatbot, of course you can do that, because Amazon Q Business provides you the API through which you can integrate that chatbot with this backend system. If you're using, for example, inbuilt UI, in that case, while doing the authentication, for example, you can have or you will have AWS IAM Identity Center through which the authentication would be done. Right, and of course there is an anonymous user authentication that is also available on Amazon Q Business. So for example, you are exposing it to, like, if your use case is such that you are exposing it to users who are not part of Identity Center, in that case you wanted to leverage the anonymous user access, that is also available. It's completely up to our customers which route they wanted to go to. Any question before I go to demo?
Yeah, so we have this another one coming in. This is let me read real quick here. Okay, so the question is about memory. How is the lifetime or memory? How does that work in any agent? Imagine I do something awesome. Next agent spin will not know anything about that. So how do you manage memory, or how do we manage memory inside of these?
Yeah, so for example, I believe that question was related to the previous demonstration on the Bedrock side, right? And probably if it is related to that, then Bedrock does have inbuilt option of maintaining memory on the agents. I just have to look up what is the maximum duration, but there is an inbuilt support for memory, and of course you also have options to store the memory externally. But I'm just unable to recollect, is it like 30 days max or something? But I don't want to commit on that. The max. That is, right. And whereas on on this one, as you are on that same chat session, right, if you're asking a follow-up question, which you also see in the demonstration, it will have that chat context part of it, right? And also if you're using IAM Identity Center login through this, then it has the chat history also, which is saved. So it takes those data in the context for the follow-up question, right?
Yeah, so pretty much, and I'm going to kind of help summarize. Anytime you're using an Amazon delivered kind of AI solution, right? Diraj is telling us, D-Raj is telling us it defaults to 30 days. It can range from 1 to 365 days. Thank you, D-Raj. He's one of our serverless specialists out there, so thank you. And yeah, so see, anytime you use an Amazon obviously built AI solution, we generally handle the memory for you. Now, under the hood, what is that? Is it DynamoDB? Is it, it may depend on different things, but we'll handle that memory for you. If you're building your own, like we'll go back to the very beginning we were talking about, look, we're going to use Bedrock, we're going to build our own solution. You can also partake of the memory that the Biswanath was talking about, D-Raj answered here. You can take part of that memory that's built into Bedrock, or you can do it on your own. If for some reason, and a reason might be that maybe you want that memory outside of Bedrock because you're calling a third party. You're calling Claude directly, or you're calling Llama or OpenAI or something like that. That might be a reason. But yeah, we have lots of solutions kind of built in, and then build your own for memory. So hopefully that answered. So yeah, there you go.
Thanks, Eric. Thanks for chiming in on that. So let's see a quick demonstration on how you can use Amazon Q Business for a similar use case. In this case, we'll be taking one S3 bucket, and we'll open a public access, or the initial settings of opening it as a public access. Let's assume that is done accidentally. And how we can identify that bucket. There may be hundreds of buckets that I have on the account. I wanted to know which one of them has this public access settings, switched off. Now, first I'll be logging into the chatbot. In this case, this particular user is onboarded onto IAM Identity Center, which is what I'm logging with. And I'll be provided with a chatbot interface. And let me prep the system. This is one of the many buckets that I have. And as you see that currently the public access is switched off, meaning that is blocked. I'll be editing it and I will switch it off, right? So I'll switch it off, meaning that it is exposable. Of course, we need a bucket policy to make it accessible outside, but that's the first step towards making it public. Now here I'm going to use this custom plugin. How this is configured, I'll come to that. I'll first show you the demonstration, then we'll get into the system. I ask a question here in a generic chat, and this can be anything that makes sense, right? For example, do I have an S3 bucket with public access? So then the job is for the chatbot to find out if there is any bucket. As I say that it has identified this particular bucket. I have quite a few buckets on my account, and it identifies that bucket and asks me a question for a confirmation. Can I remove that public access? So this is where, again, human in the loops comes into the picture. You might want to have that. You might want to bypass as a customer's choice. And then once you give a confirmation, then it takes that action and performs this, right? So again, I'll refresh this page and let's see this particular public access would be switched off. So that's how it works. Now we'll understand that how does it work behind the scene. So we'll go back to the Amazon Q Business Console. Sorry, if there's a question, or I can.
Yeah, we have one. We have one question. If you want to run with this, we can also kind of push to the end, or I'm glad to see them. But so I've always been scared to learn or use Kubernetes. Me too. Yes, understand that statement. Can you give us an example using AI, how to use it without getting technical? I don't know if you want to run with that, or if you'd like me to.
So probably I can park this question and just explain this demonstration and come back to that.
Okay.
So yeah, so I'll probably go back a few seconds as I was sharing that question. So once this is this is switched off, as you see that. Now, how does this configure? So this is the custom plugin, and again, the structure is pretty much similar to agent. So here we have the OpenAPI specification. The differentiator here is that the implementation can be within AWS, even outside AWS, whereas in Bedrock, it is currently implemented using AWS Lambda function. But here, all it needs the access to that URL, the API endpoint. And then you define the APIs and the operations supported, and similar to pretty much what we have on the Bedrock side, you be as descriptive as possible. And then you also onboard the user if you're using it. So here I have this user, John Doe, which is onboarded onto IAM Identity Center. How do you onboard that? Of course, we have a detailed documentation on that. So you can also have, for example, organizational SSO. Most of our customer uses single sign-on. You can also have single sign-on configured using the IDP that you must be using. In this case, I'm using a standalone user, so that's how I have registered it. So this is like underneath how it is working. All you need to configure is the custom plugin and provide the user access. You have choices to use that inbuilt UI, chatbot UI, which I used in this case, or you can build your own UI and integrate it using the API that it offers, right? Now, coming back to that question, like if I understood that question correctly, can we manage Kubernetes cluster using Agentic AI solution, right? Is that the question?
No, I don't think that's the question. I think the question is more I mean, maybe it is. We could come at it from two sides. I'll come at it from the first side, and then you come at it from that side. Does that make sense? I think the answer that I have is how do I do this in Kubernetes? Well, if first of all, it's kind of a comparison of apples to apples, right? So, or apples and oranges. So Kubernetes is a container management system, right? It's obviously well known. It's a very good one. We run it on EKS here, but it allows you to control containers. So you're talking infrastructure, what happens in there. So you could go about building AI in Kubernetes. You could run your own models. You could do those kinds of things. But I would ask really hard before I do that. If you think about so this again, we're going to get both ends of this question. But if you think about running your own model in Kubernetes, let's say you want to run Claude in Kubernetes, well, it takes a pretty hefty machine to do that, right? Even if you're running just the LLM and you want to open it for people to run that, you're going to need some hefty machines to do that, and they got to be up all the time, whether you're using them or not, right? Versus Bedrock, I only pay for what I use and they're already there. So that's already kind of done for you. And so much stuff is built in, the knowledge base, the guardrails, the prompt routing, and I could go on, memory, things like that, that if you do it on your own, you have to build on your own, right? And so you kind of build that in. So Kubernetes, great for running containers. Lots of companies do it. And yes, learn that if that's what you're looking to do. But if you're looking to run AI, it may not be the right fit. I would start with the managed service. Now, the other side of this is, can you manage EKS with this system? And I'll pass it off to Biswanath.
Thanks, Eric, for clarifying if we should build Kubernetes as the solution for building Agentic AI. Now, let's talk about the other side of the things. Let's say you have a Kubernetes cluster and you wanted to do the AIOps on top of it using one of the solutions. Absolutely, you can do that, right? If you see the architecture that I discussed so far, both for Bedrock as well as for KubeBusiness, it all depends on how you are integrating with and to whom you can integrate with. So I showed examples with EC2 instances. I showed examples with S3 bucket. All these are based on APIs or SDKs that I'm using. So Kubernetes definitely offers you EKS, for example. Even if you're talking about ECS, which is a container, AWS is proprietary container services. So if you are trying to manage that, definitely you can manage with this. And also I'll be talking about the next service, which is Amazon Q Developer. There, even without writing a single line of code, how using just the prompt engineering, you can do the troubleshooting on any of the AWS services. That also is possible. So yes, to answer that question, can we manage Kubernetes operations using these Agentic AI solutions, any of the three Agentic AI solutions that we'll be discussing today? Yes, absolutely, we can do that.
All right, we had another question come in, and I'm going to try to tone down. I've been told that my voice is very loud and sharp, so I'm going to talk a little softer. Not the first time. My wife would be up here going, so thank you for saying something, Bevan. I appreciate that. But we have a question here from Brazil, Wilbur Jose. And the question is, it's a good one. How's the cost of the solution? Is there incentive of AWS to get on sale?
Yeah, so cost is, if you look at Bedrock pricing, for example, right, it has pricing based on the token usage, right? So 1,000 token and based on the input token and output tokens. Of course, there are a lot of nuances around the pieces that we're using. For example, we are using the OpenSearch serverless, so there is OpenSearch serverless cost. So of course, we like, depending on the use case, we can help our customers to come to the right cost estimate for this. As we seeing a demonstration probably does not make a estimation for the demonstration piece of it. So when we work with customers, we do the estimation for their specific use case, and we always would refer to the pricing page for the different components on that. But it's a serverless offering if you're using one of the existing models without any fine tuning. So it's like as much as you use is pay as you go model that we would be looking forward to. I know this is a very high level answer to that question, but it requires a lot more details to give a very specific X, Y dollar, right?
That's right. Yeah. Okay. Ready for the next part.
Sure. So like before, if you wanted to try this out on your own account, we have published this as a workshop. Eric, if you don't mind, if you could share the link in the chat. And if you're watching it offline, maybe you can scan this QR code to get to this workshop. And it's pretty much self-explanatory with all the instructions that you can use to build this demonstration on your own account. Now we have covered the second service. Now we are going to cover the third one, which is Amazon Q Developer. And in this case, we're going to use Q Developer CLI along with MCP server integration. And this is really cool. You'll see the power in a moment. In the previous solutions, we did talk about writing the Lambda functions, exposing the API gateways. In this case, it is even at a higher level. You would not be writing the Lambda functions. You can pretty much use existing features. Along with that, you can make it even more powerful using MCP servers, right?
I'm going to interrupt you for a real quick second here, just to say this, okay? QCLI, my favorite by far. I love all the other ones. The browser plugin, incredible, I use it all the time. But QCLI is just, I don't know how to say it, it's just cool. It works in the CLI. I don't want to steal your thunder, but watch this. You're going to love QCLI. I think, Joe, you put that as your favorite also. I pretty much have QCLI. I'm trying not to get loud. I get excited. I have QCLI open all the time, just sitting over to the side. Oh, let me ask QCLI. I mean, it's so cool. So, all right. I'll be quiet. Go ahead.
Absolutely. I mean, I love using QCLI. It's like so powerful. And along with the MCP server integrations, it's not just on the AIOps solutions, of course, kind of like if you just park AIOps for a moment, if you're doing some fresh development, if you are trying to generate documentations, architecture documentation based out of our existing code, or if you're trying to do modernization, migration, pretty much all you'd like to do is use simple commands. You don't have to write any codes like any other. Configuration is all pretty much available to you out of the box. And if you wanted to extend the functionality using MCP server, as you see on the, if I can zoom in a bit, I learned that technique right in this call. So so here, a single file, MCP JSON file, in which you can have this piece of snippet and you're ready to go, right? In this case, I'm using the Bedrock knowledge base. So I'll be taking those two use cases that we already discussed. Along with that, I'll be doing one more use case to show the power of Q Developer CLI along with MCP server integration. But it's a lot more powerful than just this AIOps as I was talking about. If anybody is completely new to MCP server, just think of this as like a very specific client server protocol, which gives you additional functionality to perform tasks. So for example, if you are reading the AWS documentation, for example, so there is a specific MCP server which you can use, which will read the AWS documentation for you, and based on that, it will give you information. In this case, I'm going to use the knowledge base server, which pretty much seamlessly going to talk to the Bedrock knowledge base and invoke that knowledge base information and perform the subsequent action. There are hundreds and thousands of MCP server out there. Also, AWS has official MCP servers, which probably will paste the link if you have.
I got you.
So there are a lot more powers given to the tool, which is already powerful. But this is where it's very important. Probably I'm kind of repeating myself. Well, with power comes a responsibility, right? And while AI and generative AI making us much more powerful, we should not hand over the control to generative AI. We should be using them to accelerate our work. We should be in control that what Developer CLI should do or should not do. This has a lot more power than probably you might initially think of. So you should be in control of what how much of it you would allow, right? So that's kind of the messaging I'm giving every now and then as I'm going through this. So 2 use cases we have already seen, so I'll be very quick in explaining that same EC2 instance, high CPU utilization. We already have a runbook, so we know the drill, right? There is an EC2 instance which is currently having high CPU utilization that was introduced through a stress command, and this is over the threshold limit. So there's a CPU utilization. This is the the console where I've introduced stress. How do I use QCLI now? So it's a single, after you configure, of course, install and everything, you get inside the Q console. And then here you see at the top, you have some built-in tools and then some of the MCP servers that I have configured. The one which I'll be using in this demonstration is this one, which is the knowledge-based MCP server, knowledge-based retrieval MCP server. By default, everything is not trusted. And this is also another thing that we need to be very mindful of, which MCP servers that you are going to use. You need to be very careful about, because there are a lot many MCP servers out there in the market. You might not want to configure, all of it just because something is there out there in the market. You need to be very careful of which MCP servers that you wanted to use in your solution. In this case, I'm using one of the AWS provided MCP server. I'll trust that, and then I'm going to ask a question like, do I have any operational issues in my account based on maybe CloudWatch alarm? If that is my requirement, I can be as specific as I want. And if you ask a generic questions, of course, based on your question, it will fetch that information. So in this case, I mentioned about CloudWatch alarm. So it looked into the CloudWatch alarm list and it figured out there are 2 issues. One of them is critical in nature, which is the high CPU utilization. And then there's something related to my DynamoDB auto scaling, but that's something probably I can take it up later on. Then I give a go ahead here that, okay, go ahead and fix this. And this is where it's important that you are in control. It's not like QCLI has been given full free hand to do whatever it wants, right? Now, what you notice here is that in this inter-solutions, I would not talk about writing any custom code. All I'd be doing is just plain English prompt. And another aspect which will come very shortly is that it can also take corrective actions. Think of like a human being. If human being is executing certain commands, maybe that is something like uploading a file onto an S3, and if there is a typo, I will, based on the error message, I will do a corrective action. Similarly, here also, Developer CLI can take corrective action if it encounters an error. You don't have to say that, okay, fine, there is an error, so take this error, correct it. It can take those self-remediating action as well. This part we have already seen. There's this English language, so I'll probably just fast forward a bit. So this is the runbook that I have uploaded on S3 bucket, and then that's what I'm using. So I identified that EC2 instance. Now I have given a go ahead that go ahead and fix those issues. Now, while it is fixing, it will follow that runbook strictly because that's what in my prompt. And then it gives that what are the actions. That runbook has 3 actions, right? So these are the 3 actions taken here, as you see. And after that, it says that, okay, but I still see something is not right. Still the utilization is above 70%. What exactly happened here? Because in this case, immediately after performing this action, it just went ahead and checked what is the utilization. It did not even wait. Like, I mean, once the CPU, the restart happens, you just give a time for the CloudWatch alarm to get reflected. So this one is very important, that we are in control. It should not like end up doing another round of remediation action. So in this case, once it came back saying that, okay, fine, there's an issue, the issue is remediated, but still there is some issue. I gave a command that, okay, wait for 2 minutes and then check. So it now is waiting for 2 minutes. While it is waiting, I'm just validating what all things it did. So it has created the snapshot as per that, the command, and then it has also restarted the EC2 instance. It has sent out an email. All those things are done as per the runbook. As you see now, the alarm is also gone, and the 2 minutes is kind of a fast forwarded video. So 2 minutes also is passed. So it is now doing that evaluation again. So that's why it is very important at which point you wanted to have that human in the loop, and at what point you completely make it autonomous for the Q Developer CLI. So now it is the CPU alarm. Sorry, please go on if you have any questions.
That's right. This is Star Trek level stuff. I mean, literally just talking. I use this a lot, and I actually turn on my voice dictation on my Mac, and I just talk, and literally like, okay, fix this, fix that. Wait 5 minutes, do this, that kind of stuff, and it's incredible. Hey, just a heads up, we only have about a minute or two left to wrap, so we'll.
Sure.
If you have anything else you want to throw in real quick.
Sure, I'll probably just go to the third demonstration and then I'll probably wrap this up. So just a second. So the use case 3 was to identify an EC2 instance which has some port open, for example. So in this case, I have a EC2 instance which has a security group, and as you see, it's open to pretty much public internet altogether, and that was done by mistake, let's assume. And then the task is to identify that EC2 instance. So in this case, again, going back to the console, we'll just give a natural language prompt saying that, do I have an EC2 instance which has this particular port open? It will go through the list, and it will identify if there is an EC2 instance down there, which has this particular port open. So it will pretty much identify, and then it will ask for remediation action. So in this case, as you see that the options are a lot more. In this case, I identified 2, and I don't have to build API integrations for each and every services like other 2 cases. Where the advantage in this the previous cases was that you not only can manage something within AWS but also outside. In this case, QDeveloper CLI. Please keep me honest here, Eric. Also, at present we are managing the AWS services only with the QDeveloper CLI, right? So, and
right.
So you choose your solution based on your use cases. That's pretty much I wanted to cover. These are some of the benefits and use cases that we already discussed. Is pretty obvious. Is to reduce human dependency, not to eliminate them, and then it helps you to accelerate, right? And the options are limitless, pretty much. That's all I have to cover. Yeah, sorry.
No, you're good. I really appreciate this. We covered a lot, and that was good. If you want to know more, obviously reach out to us. He's already ahead of the game here. He's got some information here for you, and we put some links in. Hit me on Twitter, hit me on LinkedIn. Again, we'll be back next week. We're here every week on Tuesday talking serverless stuff, talking Gen AI in the lens of serverless, and we really appreciate it. With that, we're going to go ahead and wrap. Thank you so much for watching. Again, just want to thank you so much for showing this. It is super cool. And so, we had a quick question. Bevan asked, so Q did a remediation according to the runbook. That is correct. Yes. And if you don't have a runbook, Q can still remediate a lot of stuff. But if you have a way you'd like it done, and it does a lot of it too, it just does the AWS CLI. It's very powerful. So, all right. With that, I'm going to sign us off. Everybody have a good day. Jeffrey, I'm turning it back over to you, our producer. Thank you for all the work you do. Take us away.